Hello my test tubes and welcome to another step preparation video. Today I'm going to be going over 2019 step 1 question 4. Oh no, I forgot to draw the line. Okay. For part 1, find integers m and n such that this is true. If you square both sides then you get 3 plus 2 root 2 is equal to m plus n root 2 squared, which is equal to m squared plus 2n squared plus 2mn root 2. I'm sorry if you can't see that. But then you have 2mn root 2 is equal to 2 root 2, so mn is equal to 1. So either because they're integers, you have either m equals -1, n equals -1, or m equals 1 and n equals 1. And also m squared plus 2n squared is equal to 3, and then again for mn equals -1 and mn equals 1, those are true, so we have two solutions to the equation, and just because they're only asking us for one of them, I'm going to have n equals 1, and so root 3 plus 2 root 2 equals 1 plus root 2. For part 2. Let's look. If f of x has 4 roots, 4 real roots, then f of x for some alpha, beta, gamma, delta, where alpha, beta, gamma, delta are the roots, is going to be alpha to minus alpha, x minus beta, x minus gamma, and x minus delta. And so grouping these two together, we have x squared minus alpha plus beta, x plus alpha beta, and x squared minus gamma plus delta, x plus gamma delta. And also, if you look at the x squared minus 10, x to the 4 minus 10, x squared plus 12x minus 2, we know that the coefficient at x cubed is going to be the sum of the roots. And we also see that the coefficient of x cubed is equal to 0, so the negative sum of the roots. So minus alpha plus beta plus gamma plus delta is equal to 0. And so gamma plus delta is equal to minus alpha plus beta. And plugging this back in, we get the equation of squared minus alpha plus beta is gamma plus delta. So having plus gamma plus delta plus alpha beta, x squared minus gamma plus delta, plus gamma delta. And so if you have S is equal to gamma plus delta, then Q is equal to alpha beta, and Q is equal to Q is equal to alpha beta, Q is equal to gamma delta, and P is equal to alpha beta, then you get the f of x that you require. And real constants S, P, and Q, finding the three equations for S, P, and Q, my first thought is to multiply out the f of x and then get the coefficients of S, P, and Q in the equation that we're given, so x squared minus 10x, etc., to match up with the expanded equation. So f of x is equal to x squared plus p times x squared minus sx plus q, and that's going to be x to the 4 plus s minus s x cubed, so that's 0x cubed as required, plus how many x squared we have, s p plus q minus s squared x squared, plus p plus q, q minus p plus q minus p x plus pq. And so p plus q minus s squared is equal to minus 10, 12 q minus p s, there's an s here, s is equal to 12, and pq equals minus 2. Okay, and showing that s squared times, showing that the equation here is true. Well, we have two ways of determining s squared, and one of them is by rearranging this. And oh look, there's a 10 here, and there's also a 10 here. So let's try to rearrange to have s and 10 on the same side, and we get p plus q is equal to s squared minus 10, which is what we needed there. And then our second formula for s squared is going to be s squared is equal to 144, so 12 squared over q minus p squared. And the 144, I think, is rather attractive, to me, because we have 144 in the equation. So if we use 144 in all of the equations, in all of the components of the equation, then we'll eventually be able to cancel the 144s. So let's do exactly that. Let's use the lonely s squared with the 144 formula, and then the s squared minus 10 with the p plus q formula, giving us 144 over q minus p squared times q plus p squared plus 8 times 144 over q minus p squared minus 144 equals 0, which is equal to 144 over q minus p squared times q plus p squared plus 8 minus 1q minus p equal to q squared plus p squared plus 2qp plus 8 minus q squared minus p squared, and then plus 2qp because the minus sign becomes plus. And the q squares and the p squares cancel out, and so we get 144 over q minus p squared times 8 plus 4qp. And it's time to remember this time that pq is equal to minus 2, and so 4pq is equal to minus 8, and so we have 8 minus 8, which is equal to 0, so all of this is equal to 0, and so in fact it is true that s squared times, it is true that this formula is correct, basically. So we know that this equation is true, and to solve for s squared, I'm just going to replace s squared with a y because I find it easier. I'm also going to expand this, so that's going to give me y cubed minus 20y squared plus 100y plus 8y minus 144 is equal to y cubed minus 20y squared plus 108y minus 144 equals 0. I'm trying to solve this, and I plug in plus or minus 1 and it doesn't work, and that's very frustrating. And the key here is, because it's a step question, you're not allowed calculators and they're asking you to solve the thing, so don't give up. Try more integers that are factors of 144. So try plus or minus 2, plus or minus 4, plus or minus 6, plus or minus 3 as well. And you don't need to go very far because I think 2 is already a solution, and then the other solutions are like 4 and 6. I don't remember, but anyway, 2 is the smallest solution, so we have y is equal to 2, so s squared is equal to 2. And then what I did to continue on solving for the quadratic here, basically, is that I have, so s squared equals 2, and so p plus q minus 2 is equal to minus 10, and so p plus q equals minus 8. And I also had originally pq equals minus 2. Solving this quadratic gives me sorry, you know how to do this, guys. You rearrange for the p's and the q's, and you substitute what you had here into here, and you get a perfect equation, and you get a perfect quadratic, and you solve the quadratic, and there's two roots, and one of them's the root for p, the other one of them's other one of them is the root for q, and I think it's something like minus. It's I forgot what the solution is, but I don't want to do it again because I'm so slow. Anyways, you get p is equal to something, q is equal to something, and you don't know which s is which because you have s is equal to plus or minus root 2, so you don't know if it's plus or minus. So what you do is you're going to plug in the s into the sq minus p equals something. I forgot what it was again. And there you find the s, and so you plug in the s into the quadratic x squared plus sx plus p, and into the quadratic x squared minus sx plus q. You set them both equal to 0, and this is going to give you the roots. And the only reason I'm not solving the roots for the roots is because I'm fairly sure you guys know how to apply the quadratic formula, so there's no point in me doing that. Anyways, I'm sorry for this rather half-hearted video. I just kind of think that the rest, like where you have to calculate the quadratic, isn't necessary for. It's not necessary to explain my full thought process because my thought process is just a normal person solving a quadratic thought process. Yes, that sentence is very grammatically correct. So, I just hope you guys enjoyed, and I hope that your exams go perfectly well. I forgot to mention in the quadratics that you're going to be solving, I think for p and maybe after for pq, and maybe afterwards you're going to have the under square root part of the quadratic formula where there's going to be another square root inside, and it's basically 3 times the thing that we worked out in the first part of the question, so that's why the first part of the question is useful. And I'm still not going to go over it, but basically use that part, and that's all you need to know.